Welcome to Homework Lib.
In this problem, we have been given that minus q charge is spread all over the quarter circle of radius a unit, and we have to determine the electric field at this origin. Considering the components of the electric field as Ex and Ey along x and y directions respectively, we will determine the electric field along x and y directions separately. So we consider a charge element of length dl here, which makes an angle d theta at the origin. So we can see that d theta will be equal to dl upon the radius a, and the electric field, we know that its direction is from positive to the negative, so it will be along the directions as indicated along x and y directions. So along x direction, the electric field will be dE cos theta, considering dE as the electric field because of the small charge, and the electric field along y direction will be dE sine theta. So we observe that dE will be equal to k times small charge, that's dq over a square. And we can observe that dq will be the charge that's present in this element of length dl. So that will be total charge per unit, the total length, that's pi a by 2 times its length, that's dl. And now we can get the electric field along x direction by integrating dE cos theta. So that will be integral of, instead of dE, let's make the substitution, k by a square into dq, which is q over pi a by 2 into dl. And now instead of dl, we can use this expression and write a times d theta, and cos theta will be multiplied here. So this will go from 0 to 90 degree, and all the constants will come out of this integral. So that will be kq by pi by 2 a cube into a integral of cos theta d theta from 0 to 90 degree. So on simplification, we see that the electric field along x direction, that comes out to be 2kq by pi a. So here we had only a in the numerator, so a square will remain in the denominator, and integral of cos theta, that's sine theta, and it's included within the limits, so 0 to 90 degree. So that will be 2kq by pi a square. So this is the electric field along x direction. And once again, we use the same idea and we figure out the electric field along y direction, which will be dE sine theta, and that will be integral of kq by a square into pi a by 2 into a sine theta d theta, and even this goes from 0 to 90 degree, and that comes out to be kq2 divided by pi a square, and the integral of sine theta, that's minus cos theta, and this is also ranged from 0 to 90 degree. So that is equal to 2kq by pi a square into minus cos 90, which is 0, plus cos 0, that's 1. And we observe even in this case that the magnitude of electric field along y direction, that comes out to be 2kq by pi a square.